today we're going to look at a system of equation word problems. The key to solving system of equation word problems is correctly writing the system of equations. The first problem we're going to look at is Yolanda and Marissa. They both babysit. Yolanda charges $5.50 an hour. Marissa charges a base rate of $20 plus 50 cents an hour. We're going to write an equation to model the amount each girl will make while babysitting. But before we do that, we want to define our variables. We are going to let x equal the number of hours and y equals the money earned. So let's start with Yolanda. Yolanda charges $5.50 an hour. That's it. So for Yolanda's equation, it's y equals $5.50 per hour. Marissa charges a base rate of $20 plus 50 cents an hour. So we want to find out when is there a time for which Yolanda and Marissa charge the same amount. Well, since they're both equal to y, Yolanda's equation equals y, Marissa's equation equals y, we can set them equal to one another. So we want to know, we want to know when Yolanda equals Marissa. Yolanda's equation is $5.50 an hour, and Marissa's equation is $20 plus an additional 50 cents per hour. So we're just going to combine like terms and solve. Subtract 50 cents from each side, and we end up with 5x equals 20. Divide each side by 5, and we get x equals 4, and that's 4 hours. So at 4 hours, the cost to hire Yolanda and the cost to hire Marissa is the same rate. Part of that question is, for what times are Marissa's charges less than Yolanda's? So you have two options here. You can put both of their equations in the calculator and check the list on the calculator. Or what you can do is put x equals 3, because that's less than 4 hours, and x equals 5 into both equations and see what their total is. So for Yolanda, it would be $5.50 times 3, and for Marissa, it would be 50 cents times 3 hours plus 20. So for Yolanda, we get a total of $16.50 when they babysit for 3 hours, and for Marissa, we get a total of $21.50. And if we did the same thing for x equals 5, Yolanda would charge $27.50, and Marissa would charge $22.50. So we're finding what times Marissa is less than Yolanda, and clearly that's this part right here. So that means that when the time x is greater than 4 hours, Marissa will charge more than, Marissa will charge less than Yolanda. Okay, moving on to problem number 2. Raj's age is 1 year less than twice Sarah's age. Tony's age is 2 years less than 3 times Sarah's age. So the first thing we need to do is define our variables. Let's do that right here. So R equals Raj's age, and we know that is 2 times Sarah's age. That looks like a 5 minus 1. T is Tony's age, and Tony is 3 times Sarah's age minus 2, and we're going to let S equals Sarah's age. So we need to write a system of equations that you can use to solve for each person's age. So just what we wrote on the other side, Raj is equal to 2s minus 1, Tony is equal to 3s minus 2, and Sarah is just equal to s. How old are Raj, Sarah, and Tony if the sum of their ages is 21? So we're just going to add them all together. So we know Raj is 2 times Sarah's age minus 1, plus Tony, who is 3 times Sarah's age minus 2, plus Sarah, and that whole total has to equal 21. So we're going to combine like terms, 2s, 3s, and s gives us 6s. A negative 1 and a negative 2, or a minus 1 and a minus 2 gives us minus 3, and that whole thing is equal to 21. Add 3 to each side, and we get 6s equals 24, so Sarah's age is 4. So if Sarah is 4, that means that Raj is 2 times Sarah's age minus 1, so Raj is 7. Tony is 3 times Sarah's age minus 2, so Tony is 10. So Raj is 7, Tony is 10, and Sarah is 4. Okay, last one on the front side. Find the value of two numbers if their sum is 12 and their difference is 4. So there's our system right there. But before we do anything, we have to define our variables. We're going to let x equal the first number and y equal the second number. So let's go ahead and write our system. So find the value of two numbers if their sum is 12. So I need the sum of x and y is 12. Our second equation is find the value of two numbers if their difference is 4. So x minus y equals 4. So you have a choice here. You can solve this system using substitution or elimination, but this one is all set up for elimination because if we look at our coefficients of y, they are both 1 and their absolute values are the same, and one is a plus and one is a minus. So we're just going to add this system, and that way we can eliminate the y. X plus x is 2x. These get eliminated, and then 12 plus 4 is 16. And if we solve for x, we get x equals 8. So now we have to plug that back in either equation to figure out what y is. I'll do it over here. I'm going to use 8 plus y equals 12, and that's going to give me y equals 4. So what are the two numbers? The two numbers are x is 8 and y is 4. And we can go back and check to see if that works in our system. Is the sum of the two numbers 12? Yes. 8 plus 4 is 12. Is the difference between the two numbers 4? And yes, 8 minus 4 is 4. Last question. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 children's tickets. Find the price of a senior citizen ticket and the price of a child ticket. So again, we need to define our variables. We're going to let x equal the cost of a senior ticket, and y equal the cost of a child's ticket. So we need to write a system of equations you can use to solve for the price of each ticket. So that's what we're going to do. So the first one, 3 senior tickets and 1 child ticket is equal to $38. The next equation, 3 senior tickets plus 2 child tickets is equal to $52. So this equation, or systems of equations, is set up for elimination because the x terms both have a coefficient of 3. So we're going to subtract these, and again, we're subtracting everything everything in the second equation from the first equation. So 3x minus 3x is going to cancel. 1y minus 2y is going to give us a negative 1y. And 38 minus 52 is going to give us a negative 14. Solve for y, and we get $14, and that is the cost of a child's ticket. Now we have to find the cost of an adult ticket. So we're going to take 14, plug it back in one of the equations. I'm going to pick the first equation, 3x, substituting in 14 for y, plus 14 equals 38. We get 3x equals 24, and then we get 8x equals 8. So an adult ticket is $8, and a child's ticket is $14. So what is the price of a senior ticket and the price of a child's ticket? A senior ticket, which was our X value, is $8, and a child ticket, which was our Y value, is $14. And again, you can substitute them both back into our original equations to see if that works, and put it back in the word problem and see if that works as well. Okay, once again it's your turn. Go to the Google form, answer multiple choice question number 1, and then free response question number 2. Submit your answer as an ordered pair. X value, comma, Y value, and then close your parentheses.